Hi students, welcome to the next topic from gravitations. And last class we have discussed about the gravitational field intensity, and this is also the continuation of the gravitational field intensity. So we'll go ahead. Gravitational field intensity, next heading, gravitational field intensity of a quarter circle, we have already seen about half circle, and this is again for the quarter circle. So we'll consider a quarter circle like this one. So we are going to find out gravitational field intensity at the center at this point O due to this quarter circle. So this is a strip of mass m, and if I am taking one small mass over here, over this region, and this is connected to the centers like this one, and this angle is called d theta, and the angle to the horizontal is called theta, and this mass is called dm. So the dm mass will give rise to a gravitational field intensity which is called dE. Always towards the center, always towards that point. That's a property of gravitational field intensity. Gravitational field intensity and gravitational forces are towards the center or towards that point because it is attractive in nature. So dE is towards, from dm, away from dm, which means towards dE. Now we will write the formula for gravitational field intensity. dE is equal to G into dm divided by r square. R is this distance. We are taking r is this distance. So gravitational field intensity due to the mass dm is given by G dm by r square. Now what I am going to do means, I know this is like a dm. This dm's can be split into two components. One is a horizontal component and another one is a vertical component. So the horizontal component nearer to theta, it's called what? Dm cos theta, and the opposite one is called dm sin theta. So we have dm cos theta and we have dm sin theta. Okay, so d equal to G into dm by r square can be split into two components because of the dm cos theta and dm sin theta. So let me take it as the whole dE can be split into two components, integral of dEx and integral of dEy. This will give rise to x component of gravitational field intensity, and this will give rise to y component of gravitational field intensity. So we'll write, let me write, integral dE for x component is equal to integral G into dm divided by r square into x component is dm cos theta. So it become cos theta. Okay, so integral dEx means nothing but x. Integral G into dm is the mass of this small piece will be here. What is the full mass? Full mass is called m. Okay, so how to calculate the mass dm in terms of m in terms of L? I can say for a full circle the perimeter is equal to 2 pi r for a full circle. Okay, so let me write it here. Full circle, for a full circle length is equal to 2 pi r. Here it is like a quarter circle. So for a quarter circle, length is equal to how much? Half circle means 2 pi r by 2. A quarter circle means pi r divided by 2. So pi r divided by 2, it's a length for a quarter circle. So pi r by 2 length, pi r by 2 length will have how much mass? M kilogram mass. M is the total mass. So its length is pi r by 2. Pi r by 2 എടുക്കുന്ന ഒരു വയർ, ആ വയറിൻ്റെ ടോട്ടൽ വെയിറ്റ് എന്ന് പറയുന്നത് m കിലോഗ്രാം. So 1 meter വയറിന് how much will be the mass? M divided by pi r by 2. That's clear. Next, what is our dm mass length? Dm mass length how much? If this radius is called r, okay, if this radius is small r, so I will keep it as small r will be here, small r. small r, pi r by 2. Capital R or small r, anything you can take, because here we have taken small r. That's what I replaced with the small r all over here. Small r. Okay. So for here dm, it's a mass of this piece of length. Only this piece of length is called mass. What is the length of this one? Length means length of this piece. This small piece what? This is an arc. So we know from mathematics, arc angle is equal to, we'll write it like this, angle is equal to arc length divided by radius. Arc length divided by radius. What is the small angle called? D theta. So the angle D theta, arc length means a dm into e length. I am giving as L dash length. So that L dash length divided by the radius called r. So L dash will be equal to r into d theta. Now what we got for 1 meter wire? For 1 meter wire, 1 meter means small like this. For 1 meter wire, suppose we will assume this is called 1 meter. For this 1 meter wire, the mass will be equal to m divided by pi r by 2. Now what is our original length? Our length is L dash. So for 1 meter, pi r by 2 means left side I am multiplying with the L dash. So what should I have to do? I have to multiply same with right hand side. So this means L dash meter wire will have m divided by pi r by 2 into L dash. Mass will be there. What is L dash? Pi r by 2 into what is L dash? L dash is r d theta. R and r will get cancels. 2m by pi will come. Will substitute will be here. Dm, it's a mass of this piece and its length is L dash. So for 1 meter wire, we have calculated the mass equal to m divided by pi r by 2. 1 meter, just 1 meter. But what is our length? Our length is L dash. This L dash, I don't know whether it is 1 meter or 2 meter or 3 meter, 4 meter. I don't know what is the value. So I have just considered its length is L dash. It may be any value. So for 1 meter, your mass is m by pi r by 2. So for L dash meter, how much is your length? M by pi r by 2 into L dash. What is L dash? L dash is the arc length. Angle into radius, r into d theta. We are substituted. Hence we got will be here 2m divided by pi into d theta. This is the value of dm. Dm is the mass of L dash length. So this is the value of dm in terms of what? Capital M. So we'll substitute here 2 into m divided by pi, already r square will be here, and cos theta into d theta. We have to know the limit of integration. This is like a quarter circle. So 0 to pi by 2 is the limit of integration, because or half circle in the total angles another 90 degree. So 0 to pi by 2. So what are the constants will be here? 2gm by pi r square constant, integral 0 to pi by 2 cos theta d theta. Okay, what is the integral of cos theta? Integral of cos theta is sin theta 2gm by pi r square. Integral of cos theta is called sin theta. Integration limit 0 to pi by 2. Now we will substitute the values. Sin upper limit minus lower limit. So sin pi by 2 minus sin 0. Upper limit minus lower limit we have to substitute. So what will get? 2gm divided by pi r square into sin of pi by 2 minus sin of 0. Sin pi by 2 is 1. Sin 0 is 0. So from this one we will get our final relation, that is 2gm divided by pi r square. This is the gravitational field intensity along the x direction. 2gm by pi r square into sin pi by 2 minus sin 0. So this is the gravitational field intensity along the x directions. Here I starting itself I told this dm is splitted into two components, dm cos theta and dm sin theta. For dm cos theta, it's along the x direction, so we find the gravitational field intensity along the x direction. Okay, so you can pause the video and you can complete the notebook. So this is the final expression for that. You can place it in a box, for example. Okay, so this is clear. So now I am going to clear the board. Okay, perfect. Okay, so now I am going to do for y component. Okay, so similarly for DE, instead of DEX, what we are going to do? We are going to do for DEY. Okay, gravitational field for y direction. So instead of cos theta, what is coming will be here. Only these changes will be here. This is called sin theta. If this is called sin theta, again integration limit from here to here or here to here is 0 to pi by 2, 90 degree. So this become, we are integrating sin theta. Once we are integrating sin theta from this level, what we are getting from here? Sin theta in the integral means what? Minus cos theta. So this become, minus will be there, minus take it outside. So what this factor will be changes within the bracket. Minus is taken outside, upper limit minus lower limit. Cos pi by 2 minus cos 0. What is cos pi by 2? Cos pi by 2 is 0. Cos 0 is 1. So this minus and this minus become, here it is called minus 1. This is 0. This minus and this minus become plus. So what you will get? 2gm by pi r square. Hence you will get the value for gravitational field intensity along the y direction. Gravitational field intensity along the y direction. Here this is like a dm we are splitted. So gravitational field intensity, here arrow mark will have a mistake. Why? Because dm is split into dm cos theta, dm sub. But gravitational field intensity in this direction means this is the x component and this is the y component. Because gravitational field intensity is towards that point, it's attractive in nature. So the resultant gravitational field intensity in this direction, which is split into two components, x component and y component. So x component we got, y component also we got, both are same. Okay, magnitude wise both are same. So now we have like two vectors, right? Now we have like two vectors. What are the two vectors? What is the direction of this Ex? Ex will be equal to, I can specifically written as Ex will be equal to 2gm by pi r square. In this case, if I want to specify the direction means minus I cap. Minus I means minus x direction. Similarly, gravitational field intensity along the y direction is 2gm by pi r square into minus j cap, because it is in the negative y direction. So now I have two vectors. One vector is along the x direction and another vector is along the y direction. How should I find the resultant of two vector? Resultant of two vector is given by ER. How to find if two vectors are there, A and B? How we are finding the resultant of two vectors? Resultant of two vector, general formula is root of A square plus B square plus 2ab cos theta. This is the formula. What is here? Ex and Ey both are same value, 2gm by pi r square. So Ex and Ey both are same, which is called 2gm by pi r square. So this I am taking as E. Now we'll substitute, both are same value, right? E square plus 2e square, angle between two vectors 90, cos 90. What is value of cos 90? It is 0. So the total value will comes as root 2 times of e. E square plus e square number 2e square. 2 will root 2, e square root 2e. So the gravitational field intensity is root 2e, or I can written as ER equal to, will substitute will be here. What is E? I know 2 root 2 into gm divided by pi r square. This is the equations for gravitational field intensity for a quarter circle. Okay, gravitational field intensity for a quarter circle. So we'll move forward. Remember these equations. Okay, the method, how we have derived the method is important. So this is clear. Perfect. So let's move to the next topic. Now we have seen like half circle, quarter circle. Next one is what? Half, quarter, then less than quarter. Less than quarter is an arc less than 90 degree. Half circle means 180 degree. Full circle means 360 degree. Quarter circle means 90 degree. Now it's a gravitational field intensity of an arc. We'll put it like of an arc. Of an arc. Of an arc. So let me consider an arc. We are going to find out gravitational field intensity at this point. So this is like this, and this is a central axis. We are considering one mass over here, one small piece of mass we can consider anywhere in the system, and here we are going to find out the gravitational field intensity, and its radius will be equal to r. So we need to consider a mass and whose length and other stuffs we need to calculate. So let me consider a mass over here, similar to the previous problem. So this is a L dash length and its mass is called dm, and to the center this makes an angle called d theta. To this area it makes an angle called theta, and this is like a symmetrical structure, right? Symmetrical structure. So left half will be there, right half will be there. Left half given as minus 5 by 2, right half is given as plus 5 by 2. Two angles are marking. So now I can say this dm in this side can be written as what? Dm cos theta. Dm cos theta. So dm cos theta is a component like this. There is no dm sin theta will come here. Okay. So now dm is a mass will be here. So now dm is a mass will be here, something like this one. So this is a dm mass. This is called dm. So we have a center line, and this makes an angle called theta like this. So this area will becomes as dm cos theta. So what is this will come? Dm sin theta. Dm is split into two components. Now instead of this, because this is a symmetrical structure, left half minus 5 by 2, right half plus 5 by 2, symmetrical structure. Suppose if you are taking one more mass will be here, similar to this one on this side also, what you will get? This angle is also theta, so you will get what called dm cos theta, and you will get something called what? Dm sin theta. So here you have one dm, here also you have one dm, but what you can see, once you look into the whole set, this dm will give rise to dm cos theta, dm sin theta. This dm will give rise to dm cos theta, dm sin theta. This dm sin theta right side, this dm sin theta right side. That is not only 2 dm. There are many dms from the center to here. dm. Here also dm. So every dm will give rise to dm cos theta, 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 dm cos theta in this direction. It will also give rise to dm sin theta, 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 dm sin theta. These two are equal and opposite. So this will get cancelled out. But what is there in the resultant? So these two are equal and opposite. These two are equal and opposite. If these two are equal and opposite, so cancel each other. But what will get added up? This dm cos theta will get added up. So I can say the gravitational field intensity over this area is equal to integral dE is equal to integral g dm cos theta divided by r square. Integral dE is nothing but E integral g into dm. Dm means again this mass we have to represent in terms of capital M. Capital M is the whole mass. Listen very carefully. I am writing capital M divided by. Okay, let me put it like this one. What is the length of the full piece wire? Full piece wire is equal to the full piece angle is phi a, radius is r. So r phi correct alla minus phi by 2 to plus phi by 2. So the total angle is phi. So r 5 meter length wire will have m kilogram mass. So 1 meter wire will have m divided by r 5 kilogram mass. What is our length? I told our length is called L dash. So L dash length will have m divided by r 5 into L dash kilogram. What is L dash? L dash is equal to angle by arc length. So we have a small things will be here, and this angle is called d theta, and this is r, and this is called L dash. So L dash will be equal to r d theta. We can substitute. So for our dm, dm is this mass and its length is La. For full length is equal to this length. This is called length. Length arc is equal to angle into radius. So this is a full length r 5. What is the value of phi? Phi in quarter circle pi by 2. R pi by 2, right? Phi is pi by 2. So r phi angle is equal to arc length by radius. So arc length is equal to radius into angle r phi. R phi ആണ് ഇതിന്റെ ടോട്ടൽ ലെങ്ത്. ആ ലെങ്ത്ക്ക് ഇതിന്റെ മാസ് m കിലോഗ്രാം. അപ്പോൾ 1 മീറ്റർ വയർക്ക് how much is the mass? 1 meter means how should I get r 5 meter ആണ്. How should I get 1 meter? I have to divide r 5 here. Divide. If I am dividing LHS, I have to divide RHS so that I will get 1 meter. 1 meter m divided by r 5 kilogram ആണ് അതിന്റെ weight. ഒരു മീറ്റർക്ക് just 1 meter. How much is our length? Our length is called L dash. L dash is the length of dm. So L dash length in the mass is equal to dm in the mass. L dash length in the mass. L dash length in how much is the mass? M divided by r5 into L dash. 1 meter nivlo. So multiplied with L dash. So we are getting L dash length will have m divided by r5 L dash kilogram. And this whole mass is called what? This mass is called dm. So we'll substitute for dm. G into dm means how much? M into what is L dash? L dash is r d theta. I have written here. So r d theta substituted here divided by r5 into. Correct? Into. So r d theta dm. R m into r d theta by r5 into r square into cos theta. R get cancels. So we'll take it outside. So gm divided by what are things constant? Phi is constant. Phi is an angle which is fixed. Phi into r square into integral cos theta d theta. I want the limit of integration. See. If I coming from left to right, because I have to move from here to here. So if I am moving from here to here, what is the angle changes? Minus 5 by 2 to plus 5 by 2. Minus 5 by 2 to plus 5 by 2. Okay, so we'll consider. So gm divided by 5r square into cos in the integral. Cos in the integral. Sin theta. So cos integral is sin theta minus 5 by 2 to plus 5 by 2. So gm divided by 5r square into sine of what? 5 by 2 minus sine of minus 5 by 2. What is sine of minus theta? Here you can see sine inside minus will be there. Sine of minus theta is what? Minus sine theta. So gm divided by 5r square. ഇത് minus sin of minus theta. Sin of minus theta equal to minus sin theta. Basic maths ആണ്. Minus sin theta. So this minus will come outside. So sin 5 by 2 plus sin 5 by 2. How much will come? 2 sin 5 by 2. This is the gravitational field intensity for a quarter circle. For a quarter circle. Gravitational field intensity, not for a quarter circle, it's a gravitational field intensity for an arc. For an arc. Okay. So we got the relations. Gravitational field intensity for a quarter, for an arc. Okay. So you can pause the video, you can complete the notebook. Okay. So let me keep it, will be here. Perfectly. Next, what I am going to do? What I am going to do means I know for an arc with an angle of phi, gravitational field intensity is the below equation, gm by phi r square into 2 sine of phi by 2. Next we will take a, for a quarter circle, for a quarter circle I know phi is equal to pi. Okay, I know phi is equal to pi by 2, 90 degree. So we'll substitute, will be here, E is equal to gm divided by phi r square into 2 sine of pi by 2 by 2. Okay, so E is equal to gm divided by 5r square into 2 sine of pi by 4. 2 sine of pi by 4. If you are substituting as 2 sine of pi by 4, which means what? Which means what? Which is called a two sine of pi by 4. Pi by 4 is what? Pi by 4 is 45 degree. So 45 degree is there. So we'll substitute again gm divided by, here also phi, what is the value of phi? Pi by 2 r square, 2 sine 45, what is the value of sine 45? Is 1 by root 2, 1 by root 2. So these two will go to numerator. Here it is pi by 2 into r square into 2 into sine 45. Okay. So these two can be written as, root 2 into root 2. So what will happen? 1 root 2 and 1 root 2 will get cancels. This 2 will go to numerator. What we are getting? So 2 into, here this 2 will go to numerator, balance root 2. So 2 root 2 into gm divided by pi r square. This is what we got it for a quarter circle, right? Just before these sessions we have derived gravitational field intensity for a quarter circle. So this is the expression for a quarter circle. Nothing will be there. Once you get this equation, what is phi? Phi is equal to pi by 2. You substitute here, you solve it. That's all. So for an arc means it's very generic. We don't know what is the angle for an arc. If it is quarter circle, you can substitute pi by 2. And next for an half circle. So what is the value of an half circle? Half circle, what is the value of phi will come? Pi, 180 degree, right? Full circle it is 2 pi, 360 degree. Half circle it is pi. Quarter circle it is pi by 2. So all these values we know, we will make use of these values, will be here to solve that stuffs. Okay. So now we are going to form a half circle. Half circle also last sessions we have seen, and this is how much? Phi is equal to pi, 180 degree. We'll substitute, the values will be there. So gravitational field intensity gm divided by pi r square into 2 into sine of pi by 2. What is sine pi by 2? 1. So what we got? 2 gm by pi r square. If you turn back your notebook few pages back, you can see gravitational field intensity for a half circle. For a half circle, this is what the equations we got. For a quarter circles we got the, now we have three equations will be there. The first equation is related to gravitational field intensity for a half circle, nothing but phi is equal to pi substituted, we will get this equations. Phi is equal to pi r square 2 sine pi by 2. Pi by sine 90 means 1. We gotten for a half circle, we got for a quarter circle, and we got for an arc. So if you know, suppose if you don't remember this, if you are not remembering this, if you have only remember this also, you can derive these two. Because if you know this concept, you can substitute for the value of phi, depends upon the shape, whether it is quarter circle, whether it is half circle, you can substitute the values and you can find the gravitational field intensity for this structure. Okay, this is the basics of this one. So the gravitational field intensity topic or intensity area. Okay, fine. So next topic, next area. So this is clear, hope this is clear. This is important. In many places while we are solving the problem, we will use all these equations there. Okay, so write it in notebook very neatly, so that it will be there for you always. Fine, great, fine. Okay, next two things we are going to see. First one, the next special heading. So far we have learned about an arc. Arc means just a wire or a pure circle, like girls are using the bangles on their hand, right? So it is something like a bangles, it's a small ring. For a gravitational field intensity for a ring, gravitational field intensity for a half circle, just for a half circle, half ring like this, and for a quarter ring like this, and for any arc. So these two cases we have seen. For an arc we have seen, for an half circles we have seen, for a quarter circle we have seen. Next we are going to see what is the gravitational field intensity at various points in a hollow sphere. Hollow sphere is something like our football, right? Our football, our volleyball ball, our football. Inside it is what? Inside it is empty, nothing. It's pakka air only. Okay, so that is called a hollow sphere, or this is also called spherical shell. So please write down the heading: gravitational field intensity. Gravitational field intensity for a spherical shell. For a spherical shell, or this is also called hollow sphere. Gravitational field intensity for a spherical shell or a hollow sphere. So listen very carefully to the board. So here we have a hollow spherical shell, inside it is empty, nothing will be there. We are going to find out gravitational field intensity at various points. One is gravitational field outside, another one is gravitational field at surface, another one is gravitational field at inside. At the center, this is distance of r, this is capital R, and this is R. So let me write the three situations over here. I have it will be here, which means outside point. Outside I can say capital R, small r greater than capital R, and surface R is equal to capital R, and inside point small r less than capital R. So we have 3 points: outside capital R greater than small r, surface capital R equal to small r, inside small r less than capital R. 3 points we have. So what is the equation? For this is a spherical shell whose mass is given as capital M. Now we are going to calculate the gravitational field intensity outside, surface and inside. So gravitational field intensity in the general formula, okay, the general formula, gravitational field intensity general formula is Gm by R square, in short, simply. So here we have 3 points. One is outside. Outside means mass is what? Gm. Distance from the center to the point is R. So it becomes R square. That's all. So the first part is over. Next one is gravitational field with intensity at the surface. It is Gm by surface distance from center to the surface is R. So Gm by r square, it is over. Third one is gravitational field intensity inside is equal to 0. Inside is equal to 0. So this is very clear, right? Gm by r square, radius distance is r, and surface is mass is m and radius is r. So this here it is just written as general formula small m. So small m become capital M on both cases, and distance from here to here is r, and distance here is r. At the surface area it is capital R, at inside it is equal to 0. Now obviously one question has to arise, why at the center the gravitational field intensity is 0 inside every point? Okay, suppose, listen to the board very carefully. Suppose I have this sphere. Okay, so I have the hollow sphere like this one. So if you are asking gravitational field intensity at this center, I'll put it as E center. E center is also equal to 0 because it is E inside. Why it is saying like that means, listen very carefully, very important. Here I have a mass called dm. Here I have a mass called dm. Here I have a mass called dm. So I am removing this line. So here I have a mass called dm. Okay. So here I have a mass called dm. Here also dm. Here also dm. So what you can say means, gravitational field intensities are towards the center. It's that mass attracting towards center. So for this case, the dm will attract like this. This dm will attract. 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 So we have many dms will be there on all over the side. So everybody is going to attract. So what happens? See, if this is one force and equal force, opposite force are cancel. Opposite gravitational field intensities are cancelling each other. Okay. So E spreaded over an area in what direction? In equal and opposite direction. In equal and opposite direction, and hence cancel each other, E spreaded over an area, in equal and opposite direction, and hence cancel each. The center it is pakka. 100% sure the gravitational field intensity at the centers will got cancel it outside. Cancel. Gravitational field intensity cancel. But what about in other than center? Because we generally written as inside will be equal to 0. Now let me consider a point not in the center, somewhere here. Okay. So here we have one dm. Here we have 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 dm, here we have dm, here we have dm, we have many dms over there. So the fields are like this, fields are like this, fields are like this. Here also the fields are like this, fields are like this, fields are like this, fields are like this. Here I cannot say it is cancel each other. Why? Because here if you are taking distance from any point, distance from center to any point, distance will be same, radius, 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 because the general equation is equal to E into, in this case, Gm into dm by r square. If you take any value will be here, your dm is constant, fixed, dm is constant. R is fixed, R is also constant. Everywhere it is fixed or constant. I can say fixed or constant. It is constant. So both case it is constant means everywhere E will be the same. But if you take one component of E will be here, what you will get? E will be equal to, I am writing the gravitational field intensity, Gm divided by R square. R will be very small value will be here. Here mass is less, mass is less. Okay, instead of doing like this one, to make it better clear, let me take it as a 2 half like this. I am considering this as a two half portions like this. Upper arc alone I am taking. For this upper arc, let me write like this. For an upper arc, okay, let me consider G into dm by r square. And for this lower arc, G into dm dash divided by r dash square. Why I am writing r dash means this radius is r, this radius is r dash. Here dm dash is the sum of all the masses. Okay, so we will write dm dash equal to sum of all masses in lower arc, sum of all masses in lower arc. Okay, here also dm, here this dm is representing sum of all masses in upper block, in upper arc. So suppose I am assuming here also in a small dm, many dms. Now I am assuming it as a two symbol structure. One is here I am drawing a line. So all these bigger areas, this is one mass. And this is the next piece of mass will be here. So for this upper mass G dm by r square, dm I am assuming for the whole upper mass. So here I am assuming G dm. Now if you see upper and lower half, in upper half mass will be lesser or greater? Mass will be less, but distance is also less. Both the numerator is decreasing. If numerator is decreasing, what will happens to the E? E will increases. Okay, numerator decreases means E will come down, but R is reducing. If R is reducing means E will go up. So because of dm, E will have a tendency to go down, and because of r square is lesser value. If denominator is decreasing, E will increases. So because of dm it is decreases, and because of r square it is increases. So one decrease, one increase, more or less constant. But if you come will be here dm dash is a higher value, increases because of full mass. It is higher than the upper arc. So dm dash is higher. Distance r dash is also higher. So for this lower arc, if you are writing as E is equal to, because of dm dash mass is very high, gravitational field intensity is increases. R dash, denominator is increasing. If denominator is increasing, what will happen? R will be reduced. So you can see more or less the lower part, this part is a constant. Increase and decrease will be there. Why increase? Because of the dm dash. Dm dash is the mass of the complete lower arc, very high mass, because it's a bigger piece, bigger mass. So dm dash is a higher mass. Gravitational field intensity increases. R dash is a distance. If r dash is the distance is also increases. If distance increases, E will be reduced, because denominator increases means this will reduce. So increase, decrease, all over it is a constant value. Here also if you see, mass will be lesser. Because of lesser mass, less gravitational field intensity. Distance is lesser. If distance is lesser means denominator lesser means gravitational field increases. So increase and decrease here, this will give rise to a constant value, this will give rise to a constant value. Both values are equal also. If both values are equal also, in the lower, this is a pakka concepts only, nothing will be that, 100% concept. So lower half and upper half are more or less equal. If that is again equal, this is similar to the gravitational field intensity in a center situation, because center it's already fixed, dm and r everywhere fixed, everywhere in all directions, so it will get cancel each other. But in this case it is also cancelling. Why? Because one is increasing, decreasing and it's constant, one is increasing and decreasing and it's constant. So lower half is giving rise to a E value, suppose it is 10. Upper half is also giving rise to a value is called 10. So both will get cancel each other. both will get cancelled each other because this is giving rise to a constant value. Now if you consider this diagram as a 2 arc like this one, this is our 1 arc and we have a bigger arc will be here like this. So these two I have separated like this one. Now this is the point. So because of the red one, gravitational field intensity in this direction. Because of the blue one, the gravitational field intensity is towards that point. So again this blue one and the red one, the blue one and the red one. So this is corresponding to the blue one. This is like upper arc. Upper arc means this is corresponding to the red one and this is the lower arc. Lower arc will give rise to a gravitational field intensity like this. Both will get cancelled each other. That's what we are saying, gravitational field intensity inside is equal to 0. Okay, this will be considered as a 2 mass instead of DM mass. A red mass, a small piece and bigger one. So bigger one is blue color. Blue color will give rise to gravitational field is away from the body, away. So it's going upward. And a red color is give rise to gravitational field away from the body. So even it's a smaller mass, smaller distance. So total it's a constant. This is a higher mass, higher distance. Higher mass, higher distance. Higher mass means E increases, higher distance means E decreases. So it is also constant. So this E and E are again equal and opposite. So that the gravitational field intensity inside a hollow sphere is equal to 0. Okay. Hope you understand something from me. Today sessions we have learned about arc, quarter circle and gravitational field intensity of a spherical shell or a hollow sphere. Okay. So thanks for watching the video and have a nice study time and study well. Understand the concept and the physics and learn the physics in an enjoyable way by understanding the concept instead of by hearting the things. Okay.